Remind me, let's record this lesson. Let's record this lesson, please. Sorry. So 1.25 divided by 3.5. We get 0.357. I said for calculation purposes, we record our answers to 3 decimal places. We record our answers to 3 decimal places. So R will be the arctan of 0.357. So therefore, our angle R will be, so the arctan of 0.357. Members, what have you got? Members, what have you got? Have you got 19 also? 19.6 degrees. Is that what you have got also, members?
Yes.
All right. All right. So now, do we stop there? Members, do we stop there? Members, do we stop there?
No.
No. So we know angle R now. Because now we know angle R, then we can find angle what? Angle what? I. So are we going to find angle I, members? What concept are we going to use? Using Snell's. So we said from Snell's what? From Snell's law. So which means we're going to have refractive index in air, sine I, equals to refractive index of the glass, sine what? Sine what? R. So what are we looking for? We are looking for sine I. So which means sine I, we are looking for angle of incidence, sorry, over G sine R over NA. But we know that refractive index of air is 1.00. So which means sine I will be equals to refractive index of glass, which I've said is 1.49 times sine R, which we have got is 19.6 degrees, divided by 1. Yes? Yes?
My screen is just dark. Black. I'm seeing only the arrow.
Then the problem is your phone now. Members, other members, are we seeing the screen well?
Yes. Yes.
Letitia, the problem is your phone, over your phone or your laptop. Okay?
Okay, I'm going to fix it.
Yeah, what you do, increase the contrast, the brightness of your screen. Yes. What is the answer? Please work for me out and get for me this answer, please. Work it out. So our sine I will be equals to, what do we have here? So we have 1.49 times sine 19.6. We get 0. Because even if you divide by 1, you still get the same value. So which means there we shall have 0.499982. But we said we have to make sure that we round it to 3 decimal places for calculation purposes. So when you round it to 3 decimal places, you shall have 0.500. If you round it off, correct rounding off. If you round it off well. So which means I will be equals to the sine inverse of 0.500. So therefore, our I will be equals to sine inverse of 0.500. Members, what have you got? Members, what have you got? Is it 30 degrees? Members, is it 30 degrees? Is it 30 degrees?
Yeah. Yes, it's 30.
Okay. Okay. So that's what they wanted us to do from that question. That's what they wanted us to do. That's what they wanted us to what? To do. Members, what if they were asking for this angle here? What if they were asking for the displacement? I mean, deviation. Assuming they were asking for this angle here, for this deviation here, angle of deviation. So angle of deviation will be this one here. I think that. Members, are we seeing that? So angle of deviation will be this one. Are you seeing this? So this will be our angle of deviation, D. So how are we going to find that angle D? Are we going to calculate that angle D? So let's say Roman 2, let's say Roman 2, angle of deviation. Angle of what? Angle of deviation, D, is going to be, what is it going to be? We know that all of this angle, what is it going to be, members? What is it going to be? We know that all of this side must be opposite to this, right? Not so? These are I and then R plus D, they are opposite angles. They are opposite what? Angles. So which means angle of incident, I, so say from I equals to R plus D because they are what? Vertically opposite angles. They are opposite angles. So which means our angle D will be equals to I minus R. So which means D will be equals to our angle of incident, which we have just got is 30 degrees minus 19.6 degrees. So therefore, angle of deviation will be 30 minus 19.6, which will give us 10.4 what? Degrees. Are we together, members? Are we together? Members, are we together?
Yes, teacher.
Yes. That's assuming they were asking for the angle of deviation. So which means this would be the angle. This would be the what? The angle. Okay? So that is question 1. That is question 1. I think the rest are clear, the rest are easy, the rest we have already done them. So let's look at question number 2. Question number 2. Question number 2. But members, are we together? Lamuno?
Yes, teacher.
Are we together?
Yes.
What did I say?
We are going on question number 2.
I thought you were dozing, Lamuno. I thought you were dozing. So this question is saying a ray IO is incident from air onto medium P, medium P at a glancing angle of 60 degrees, full stop. If angle beta, is 172 degrees, comma, find the refractive index. Find the refractive index of medium P. That's what they want. So the figure is here. Let's have a sketch of it. So this is the refracting boundary. We have the boundary there. So this is our boundary. Then there's a normal line here. We say normal line must always be dotted because it's an imaginary line. It's not real. So we have something like this. Then from here is refracted like that. So light is moving like this, like that. So this is our I, then this is our point O, then this is our point R. That's our point R. So that we said all of this angle here, all of this angle is beta. That angle is what? Beta. So this is air, then this is it, medium what? Medium P. That is medium P. My dear students, are we together?
Yes, teacher.
Yes, teacher. Okay. So have you finished drawing that? Have you finished putting that question down? Okay. Now, when you look at the question, what do they want us to find, members? What do they want us to find?
The refractive index.
So what are we going to do? Because when you read through the question that said a ray I what? IO is incident from air onto medium P at a glancing angle. What will be the glancing angle, members? This is the glancing angle, not so. Because glancing angle is the angle between the incident ray and the refracting boundary. And the refracting what? Boundary. So this is 60 degrees. So what is this angle called? This is called angle of what? Incidence. This is our angle of what? Incidence. I think that, members. I think that. So if our angle of incidence, is I, but we know that we can find the angle of incidence because we know the glancing angle. We know that glancing angle plus the angle of incidence must give us what? Must give us 90? Must give us 90 degrees. So which means angle of incidence will be equal to 90 degrees minus the glancing angle G. Okay? So means what is our angle of incidence? So it will be 90 minus 60. So what is the angle of incidence? Our angle of incidence will be equal to 30. 30 what? 30 degrees. 30 degrees. But now we cannot stop there. We cannot stop there. So we have to go ahead. We have to go ahead and find this angle here. What will be this angle now, members? What will be this angle here? What will be this angle? Actually, how are we going to use this 172? We can use 172 to find this angle here. We can use it to find this angle. Are you seeing this one here? Are you seeing this one, members? Only these. Okay? Okay? Let's call that angle. Let's call that angle theta. Let's call that angle what? Theta. So now if that angle is theta, we know that, which means I, okay? Okay? So when we, you know, all of this angle from here up to here is 172. Is 172. But this angle from here up to here is what? 90, not so? This one is what? This one is 90. So I plus 90 plus theta must give us 170? 172. Good. So we shall say I plus 90 degrees plus theta must give us, must give us 172 degrees. Members, have you understood the geometry there? Did you understand the geometry I've used there? Because all of this angle from here to here is 172, but we have got this angle is I, but this one is 90 degrees, then this is theta. So once we get theta, we can find this angle because this angle of refraction. This angle is what? That angle is what? Angle of refraction, R. Not so? So let's go ahead. Our I is 30 degrees plus 90 degrees plus theta is equal to 172 degrees. So which means we'll have 120 degrees plus theta is equal to 172 degrees. So our theta will be 172 degrees minus 130 degrees. I mean minus 120, sorry. Minus 120. So theta is equal to, what do you get, members? 172 minus 120. What do you get? Is it not 52? Is 52 degrees. But we know that for us to find the refractive index, we need only the angle of incidence and the angle of refraction. So I'm going to find the angle of refraction here, members. So R plus 9 plus theta must give us what? R plus theta must give us 90, not so? Not so, members. R plus theta must give us what? 90 degrees. Also, yes. also, R plus theta must give us 90 degrees, which means R is equal to 90 degrees minus theta. So our R will be equal to 90 degrees minus 52 degrees. So what is our R? What is our R? 90 minus 52. What do you get? We get 30?
38.
38.
We get 38 degrees. So that's the angle of refraction. That is the angle of what? Refraction. But the question wants us to find the refractive index of medium P. And remember, is moving from air to medium P, So we shall say using Snell's law, what? Snell's law. So which means we shall have NA sine I, not so, equals to NP, because I don't know the medium P. So it's a refractive index of medium P, okay? Sine what? Sine what? Sine R. So which means it implies that NP will be equals to NA sine I over what? Over sine what? Over sine R. So NP, we shall have 1.00 times, what was our I? Members, what was our I? What was the angle of incidence?
30 degrees.
Was 30 degrees over sine of angle R, which is what? 30 what? 30?
38.
So can we press that? Can we prove that? So 1.00 times sine of 30 degrees, close that, divide by sine of 38. What do we get? 0.8?
0.8.
0.81, not so? So that's the refractive index. That's the refractive what? Index of the what? Of medium P. That is the refractive index of medium what? Of medium P. Are we together?
Yeah.
Yes. Tracy,
Yes,
how are you, Tracy?
I'm fine.
How is the leader?
It's okay.
Leader is okay, eh?
Mm.
Okay. Even Kampala is okay. Kampala is also okay. I want to see people from up.
Teacher,
Yes? Yes, Lynette.
Teacher, can you help me? Can you help me first press the calculator again to get that answer?
Okay. It's like this. Open a bracket. Open a what? A bracket. 1.00 time sine of 30 close. Okay? Okay? Divide by sine of what? 30? Sine of 38. Have you seen Lynette? Lynette, have you seen?
Yes,
Okay. So members,
I have seen.
is there any question? Is there anyone with any question on how to calculate this question, on how to work out this question on a refractive index? Is there any question on that? Is there any question? We are together, right? Okay, okay. That is fine. That is fine. That is fine, members. That is fine. The next question, which number is this now? Question number? Number what? Number 3. So let's write this question. They're saying the figure below shows a semicircular prism, glass prism, a semi-glass prism with a ray of light, traveling as indicated, full stop. If the refractive index if the refractive index of the material, if the refractive index of the material of glass is 1.52, comma, calculate angle marked X. Calculate the angle marked X. So this is what I've drawn for us. They've drawn this one for us. It's a semi-glass prism like that. So at some point here, they put there is a normal. We know there must be a normal point. So a ray of light is traveling as indicated like that. Then like that. So it's traveling like that. Should have said all of this angle here, all this angle, this one here is 120 degrees. Then this angle would have said is X. This angle is X. Then this is the semi-circular glass prism.
Excuse me, teacher.
Yes?
Is the outside of that semicircle also glass?
Here.
No?
Yes. This
Down.
one. This one.
The outside of it, yeah.
Light is, in this case, we are going to consider because it's entering through, it's from glass to air. This is air, okay? Okay?
Okay.
Yes. So this is glass, then this is what? This is it? Air.
Isn't the light ray supposed to be from where the arrow is?
Here.
The outside of the semicircle, yeah, into the semicircle.
From here. No, the arrow just showing is moving from glass to air. It's from glass to air. Okay?
Okay.
Yes, just take it from glass to air. So we have 4 minutes remaining. Can you work out the angle X? Can you work out the angle X? So from there, who can tell us what is the angle of incidence? I can see the answer is already there. What is the angle of incidence, members? What is the angle of incidence? Our angle of incidence is this one, right? Is this one, right? This angle of incidence. Then what is this angle, members? What is this angle? That is the angle of refraction, right? So when you look at the figure very well, what is the angle of incidence? You know that this angle is 90 degrees. This one is 90 what? 90 degrees. But from here up to here is it 120. So what is the angle of incidence?
30 degrees.
Is it?
30.
Perfect. Perfect. So angle of incidence is going to be from I, not sir, plus 90 degrees is equals to 100 and what? 120 degrees. So angle of incidence will be 120 degrees minus 90 degrees. So angle of incidence will be equals to 30 degrees. Now, what you should do here, you go ahead using Snell's law. Using Snell's what? Law, find the angle R. Find the angle what? R. So you said from Snell's what? From Snell's law. So which means you'll have Ng, because it's from glass to air, sine I equals to Na, sine what? Sine what? Sine R. Sine R. So which means sine R will be equals to Ng sine I over Na. So sine R will be equals to, refractive index that I've said is 1.52 times sine of 30 degrees divided by 1.00. So sine R will be equals to 1.52 times sine of 30 degrees. We get 0 point what? 76. So R is equals to the arc sine of 0.76. So R will be equals to what have you got? Members, what have you got? What is R?
49.5.
49.5. Good. 49 point what? 0.5. 49.5 degrees. But we want angle X. They want us to find angle X. See? So how are we going to find angle X, members? How are we going to find X?
R plus X is equals to 90 degrees.
Excellent. Excellent, members. R plus X is equals to 90 degrees. So which means X will be equals to 90 degrees minus R. So X will be equals to 90 minus 49.5 degrees. So what do you get? What do you get? What do you get, members? You get what?
40.5.
40.5.
40.5 degrees. Have you seen that, members? Have you seen that? So we have less than a minute remaining. So when we come back, we shall continue, please. But if there's any question, you can ask me. Because when we come back, we shall not look at this. Yes? Yes?
Is it okay when I round off?
Don't overround, Lamuno. Put it to 1 decimal place, okay?
Okay.
For angles, you put it to 1 decimal place. Don't overround. Okay?
Yes.
Yes.